Okay, so welcome back. Now what we're going to do is we're going to show you how to write vectors in the rectangular plane. Okay, so based on the unit vectors, what we can actually show you, what I'm going to show you is that we can write actually any vector as component vectors or the sum of component vectors using I and j. Using basically the same kind of method or same kind of thing that I did in the last video. So let's take a couple of just random points. Let's say this is the initial and terminating point of a vector. Okay, so we know that if we can take, we can take any vector and write it as a position vector in standard position. So that's one. And then we also know that we could take any position vector and write it as two component vectors, one in the vertical direction, one in the horizontal direction. And then furthermore, based on what we just did in the last video, we can represent those component vectors in terms of I and j by using scalar multiplication. So if we put it all together, we can take any scalar, we can take any vector, right? We can use the position vector and we can split it up, right, into its component vectors and represent each one of those component vectors as a scalar multiple involving I and j, which means that any vector that we come up with can be written as a sum of those two component vectors, right? So it can be a times I plus b times j. So what I'm getting at is that any vector can be written in the form of a times I plus b times j. Because if I have a vector right, then I will have this component do that better. Okay, oops, sorry. And then I've got this component. Yeah, let me go a little higher. Okay. And if this is v, right, then I know that this component is, regardless of how long it is, it's going to be some scalar multiple, right? So this one's going to be some scalar multiple of what? I, which is what? In the vertical direction, which is 1, 0. So I know, again, a scalar multiple changes the length of the vector, but keeps the direction. So I could take any scalar multiple of I, which is 1, 0, and I can get this component vector, right? In fact, I can get this particular component vector. And likewise, I can get this component vector by just doing some scalar multiple of 0, 1, which is j. So that means, again, if I add this vector to this vector, right, I know I'm going to get my resultant vector, right? So I know that I can get v by adding this vector plus this vector, which gives me this, because this vector is j, and this vector is I. So I can get any vector, I can represent it as the sum of the scalar multiples of the component vectors I and j. Just based on what we've done so far. That should make sense, right? So now, we already know how to get it as a position vector, even if I have 2 points, right? How do I get it into a position vector? By subtracting the corresponding coordinates or components of the vector, of the point, right? So, how does that work into our formula? Well, A is what? A turns out to be equal to what? x2 minus x1. B turns out to be y2 minus y1, which gives us the general form that if I give you any 2 points of a vector anywhere in the plane and I want to represent that vector in terms of I and j, then it becomes the vector is equal to x2 minus x1 times I, right, plus y2 minus y1, oops, not a vector, parentheses, times j. Okay? And again, I is the vector 1, 0, and j is the vector 0, 1. And again, literally, I can take any vector in the rectangular plane and I can write it as its component vectors of I, as a sum of its component vectors I and j. Or a scalar multiple, some of the scalar multiples of I and j. And that's it. So let's do an example, and we'll see you then.